Hey guys, okay, we're gonna get started on fractional coefficients, and we're gonna work these very similarly to how we worked the business with the complex fractions. Starting with my version of example 1, you've got others that you can refer back to in the book. You're gonna notice that I leave a space in front of each fraction, and that's so that I have a place to put my lowest common denominator that I'm gonna use to clear my fractions. Okay, this entire lesson is predicated on the fact that if you clear the fractions, it makes these a whole lot easier to solve. Sorry about that. So each of these has an LCD of 18. We're going to use some stuff we've learned in days of old as well in this lesson, especially in example 3. That'll come up shortly. 9 and 18 reduces to a 2x squared. 6 and negative 18 reduces to a negative 3. 2 and 18 reduces to a 9, and all of that equals 0. Now, for sake of time, you all know how to factor this. The end result of the factor is 2x plus 3. X minus 3. And you can do all that on your own. After you've factored it, you solve for 0. 2x plus 3 equals 0. So in this case, I'm going to have a negative 3 halves, and x minus 3 is 0, so I'll have a 3. So my solution set is negative 3 over 2 and 3. Okay, that's example 1. Example 2, I'm going to do 2 of them with you just to kind of give you a taste of what those are like. Example 2, we'll start with this one. So if I have example 2, x minus 14 over 4 is greater than or equal to 5x over 12 minus 3. Lowest common denominator of all of that is going to be 12. Multiply each piece accordingly, and you will clear your fractions quite nicely. Now, this step right here, this 3 gets multiplied by both the x and the 14. Do not miss that. It's not just getting multiplied by the x. It's both pieces there. So you should end up with 3x minus 42 in that first position. 5x minus 36. I like to keep my x's positive, so if I move my 3x over here, I have a 2x. And if I add my 36 over to the other side, looks like I end up with a negative 6. You guys know how to make all those moves. Dividing everything by 2, x is less than or equal to negative 3. Now, a warning for you. If the 2 were a negative, you must flip the less than or equal to, greater than or equal to symbols whenever you have a negative coefficient. We don't, but if you did, you would have to. Okay? Last example, and we're going to do another greater than, less than one, because this one's tough. Y squared added to 4 over 6 plus, I'm leaving a space so I can fill in my multiplying denominators. Makes it easier for you. 3 halves. 6, right? Right. Once you do all your reducing, you're going to end up with nothing there because it canceled. 2 Gets multiplied there and there. Another warning for you, if this were subtraction, then it means you're subtracting this entire piece. So you would have to flip the sign of both of these pieces. This is addition, but if it were subtraction, you have to take that into consideration. So far, so good? Let's combine like terms and move that over. So I think I end up with y squared plus 2y plus 6. Move my 9 over, y squared plus 2y plus negative, we'll just make it negative minus 3. Factoring it, this is where you might feel a little tricky, is y plus 3 times y minus 1 is less than 0. This goes back to that lesson where the product of these things is a negative because they're below 0. So you need to solve these as if one's positive, one's negative, and then solve the other side the other way, okay? So we're gonna make y plus 3 greater than 0, y plus 3 less than 0. Do the same thing here, y minus 1 is less than 0. See how they're opposite? Because opposite signs produce a negative, and I need a negative to be below 0. Y minus 1 is greater than 0. So in this case, I have y is greater than negative 3, and both of these things have to be true. Y is less than negative 1, greater than negative 3, and less than negative 1. And I have less than positive 1, goofball. Over here, I have y is less than negative 3 and y is greater than 1. This can't exist. Something cannot be smaller than a negative 3 and greater than a negative 1, which means your solution set is negative 3 y 1. That is the only solution set that would work. This one doesn't exist in the known universe. So be very careful. That is going to be, I think, numbers 22 and 24. Well, 21 through 24 in your assignment are going to look like that. So make sure you be careful with the inequalities and how you identify and solve.